Thanks for joining us today. I'm Ivan with Enviropeel. For those that don't know, the product is a thermoplastic polymer, has a built-in corrosion inhibiting oil. The product is a sprayable liquid. It's normally a flexible solid, but you heat it to a sprayable liquid, melt it in the machine, pump it through a heated hose and gun right on the substrate. Once it hits the substrate, it cools back to ambient temperature very quickly, and then back to its solid state. So there's no chemical process in it. It's just heating it to liquid, letting it cool back to its solid state. The unique characteristic of the product is that it does not bond anything except itself. So in cases like rotating equipment, you can encapsulate the bearing housing, extend the coating onto the shaft. Everything rotates freely under the coating, like you didn't have the coating on there. Used for it in rotating equipment is to prevent contaminants from reaching your primary seals. It's not replacing your primary seals, it's just a deterrent to any product seeing the primary seals. Originally, the product was designed just to be a corrosion prevention product to be used in molded assemblies, valves, flanges, in oil and gas, saltwater environments. And also it's used to protect stored mining equipment a lot in Australia. And it was kind of accidental. Some guy storing a bunch of bearings on pulleys just to keep the water out of the bearings during storage, left it on the bearing to see if it would help keep propagation contaminants during operation. And they did. It actually increased those bearing lives by like 500%. So that started the rotating equipment protection vertical for us. But the product's still used in all three categories. So if you have a machine surface, shafts, or something that's tight tolerance, you don't want the flash rust, it's going to sit outside, or it's going to sit in an area that could rust. You put just a single layer of this if it's indoors, or 2 layers if it's outdoors. The product will stop any existing corrosion and prevent future corrosion. And then to remove it, you're just slicing with a razor knife, peeling it away. And it just reveals the substrate with a thin layer of that inhibiting oil that's mixed in with the plastic. So primarily today we're talking about protecting some bearings you guys are having some contamination issues with. The basic concept of today is how to operate the equipment safely, how the product is applied functionally, but understanding that you're probably not going to be expert applicators at the end of the training, and then just how the product functions. So guys, it's not rocket science and I can do it, so it may take some practice, but the good thing is any practice you do in the shop, as long as you reclaim the material in a clean bucket or something that's very clean, you just don't want to put contaminated material back in the machine. Any clean material you put directly back in the machine and you want it to spray. So a little bit about the equipment. It's 220 volt single phase, or it can be run off 12208, just 2 phases of that. Requires 30 amps. Hazards are obviously you got really hot material. The product's getting sprayed at about 338 degrees Fahrenheit, so it'll burn you. So proper PPE is important. Leather gloves, sleeves, obviously the main stuff you guys wear. Safe glasses at a minimum, and a face shield if you're spraying up under something, or if you're working with someone else that's spraying across from you. That's the most dangerous area because I can spray you from here. And that's the way the most injuries we see happen is to other people. So we recommend you keep kind of a 12-foot berth around what you're spraying. It's great theory, but as much as you can do that, it minimizes injury. The other thing is obviously electrical shock. With hoses and boards, you got trips and falls. I showed you how to turn the machine on. There are 3 heating zones. So right now there's material throughout the entire system in the tank, which holds about 2 buckets of material. And you want to keep full to the top of the fins all the time. What that does is you start getting burn off in the tank. If you let it get too low, it starts smoking more out of the tank. And then you also get less efficiency because as you empty the tank, your melting rate is decreased. When you turn the machine on at first, the tank initially just starts heating. It climbs up to the 338 degree melt range that we want to spray at. Once it gets to that temp, it drops some heaters out and turns on the hose and gun to heat. Comes up to temps usually from being cold in the morning to up to temps about 40 minutes, 45 minutes. And then we're good to spray once you adjust your pressures. You'll notice there'll be quite a bit of steam coming off of that. We may want to open that overhead door just because it stinks. We have the non-toxicity data for the vapor. As long as you're in a ventilated area, it's not harmful. If you're in a confined space, you want to wear some sort of respirator or something, but you'll notice the scent, but don't be alarmed by it. It stinks a little bit. A couple other things. The most expensive parts of the machine are the hose and the gun. They're about, I want to say, $7,000 for the assembly. So biggest issue are kinking and running over the hose, dropping the gun at height. They're all very durable components, but everything has its limitations. If you have to replace that, that's the most expensive part. The other wear items are the motor and the pump. The pump has good longevity as long as you're not running dirty material. So we can show you some stuff a little bit more on the maintenance of the machine. There's very little maintenance to do on it, but we can go through that a little bit later. But right now we're up to temp. And any questions before we get started?
How often do you clean it?
Clean the tank out?
Yeah.
So we recommend you back flush the filter every 8 hours. There's an hour meter on it. I'll show you how to see the hour meter. And then you may want to strip the tank maybe quarterly. Just run the tank empty back into something you can reclaim the material into. Trays or something, cut it back up. And then when the material is just warm, not hot, you can peel it out of the bottom. So any contaminant that's settled out, just peel out of the tank. The hose and gun, you should never have to do really anything with. When you're done spraying, at any point, just shut it off, pull up the hose in the machine, and it solidifies in the hose and gun. And then reheats there as well next time. Good question. When you start the machine at first, you want to make sure you open the back door, uncoil the hose, make sure there are no kinks in it. You just don't want the hose to be heated up inside the machine. It builds exponential heat on itself because it's side by side, and it can get too hot. Probably won't, but just uncoil that before you turn it on. We're going to turn it on. It's a PLC drive or control. It's going to go through its warm up cycle. And what you'll see here is the actual temperature of each zone. There are 3 heating zones. So the material's heating now throughout the entire system. So when you're finished spraying, you just shut it off and it cools that back wherever it's at. You don't have to flush the hose out, clean it out. The way these operate, the tank out of the gate starts heating before the other 2 zones start. When it gets up to temp, which now it's set at 338, that's usually the default where everybody sprays. If it's really windy and cold outside, you may want to turn it up. It won't go up past, I think, 355. It won't even let you set it that high. But if you want to set it, you can hit the set point, plug in your desired temp, hit enter, and then all 3 zones are going to default to that high temp limit. So right now the tank temp is rising. The other 2 are not because we have all 6 heaters in the base of the tank engaged with maximum amp draw to get that tank up to temp as quickly as possible. Inside here, this holds about 2 buckets of material, so there's already close to 45 pounds in there. Once you get up to temp on the tank, it will kick out 4 of those heaters, keep 2 engaged so that you're maintaining that tank temp, and it'll start heating your hose and gun. So from the time you start it till the time you're ready to spray is usually about 45 minutes initially. This is your pump. You can turn it off and on. It will not start until you hit, I think it's 265 in the tank, because you don't want to try to turn solid material.
Right.
The product is single component, so all we're doing is taking a flexible solid, heating it into a liquid, and then when it hits the substrate, it cools really fast back to its solid state. There's no chemical reaction taking place. It's just a heating and a cooling. This is your flow control. When you're ready to spray, you can adjust the flow of the material through the hose. And then we add air at the nozzle to help give us some fan texture. So those are your two adjustments. This has an onboard air compressor. So that's going to give you the air when you do set your air pressure at your nozzle.
Right.
That air is only added at the tip. So it's not helping propel your product through the hose or anything. It's just helping fan it. Before the material goes into the hose, it goes through a mesh filter. It's behind this fitting. If you run contaminated material through the machine, it will clog that filter. So you want to make sure you're always using clean material. If you're reusing material, it's pretty rare unless you're in a shop setting and like coating something that you can maintain your cleanliness. If you do run contaminated material and you start losing pressure at your nozzle, there's a back push valve right here, and you'll open and close it about 6 times and let that product just pool at the bottom of the machine until you have a little puddle. Just let that cool. That should be taking the contaminants away from your mesh filter, dumping them out. You just throw that away when it's cool. There is a trigger lock here. So up, can't even squeeze it. Down, you're ready to spray. On the front of the machine, there's a button for turning the pump on. When the screen is backlit green, it's ready to spray. When it's red, it's not up to temp yet. So we'll turn the pump on. The pump will not turn on until the tank gets to a temperature that it won't hurt the pump. It's not trying to turn hard material. You'll notice that the material is just pumping up through the center of the tank, through that hollow tube, just recirculating itself during startup. So we have very little pressure to the gun at this point because all your pressure is going through the middle of the tank. The flow control here adjusts your pressure and diverts it from that inner tube to the gun. You're going to want to set your stream something about like that. It's a feel thing too. You may have different preferences as you learn to spray. And then once you get your flow to the desired part, you start adding air. These are just auxiliary air outputs that you can use for blowing off substrates or whatever. We're trying to get to a texture that looks something like this. So if you're spraying the bottom of the lid, it would. We've been heating about 40 minutes. We run out of material pretty quickly up on startup. We've already dropped tank temp down since I was recirculating, so it's now going to show red for a minute. Once we get the tank temp back up, it'll show green again.
Are we going to put in product right now?
We're good for right now, but you just want to keep it about the top of the fins. So every few bearings you spray, just throw in a couple of handfuls of product.
Just want it to be over the fins?
Yeah, so we could put in a little bit. Someone wants to grab a pocket. So in the material, if you grab a few chips, you can feel the oils that leach out of it. And that's what's going to leach onto the surface under the coating. And,
You want to take
just bond
one,
it.
put your hand in
Do
there?
that if you want. I would recommend it.
No, raspberry sour. That's good.
What is the max you can fill up?
Just to the top. And it's designed to run back into itself. There's a lip, but
Yep.
as long as your lip can close, there's a lot of air in those chips,
Yeah.
like between them, so it'll melt down pretty quick.
Sure.
Rule of thumb for coverage rate: a pound of product will cover about one square foot, or a pound will cover about 1 inch diameter shaft size. So if you have a 3 7/16 inch bearing, it's probably going to take about 3.5 pounds of material to cover the housing and the shaft assembly. One question we always get is, does it increase the temperature of the bearing because you're now insulating it? You'll see how when we spray it, the product dissipates heat really fast. So we don't see any real appreciable heat increase. If you're using thermography to monitor your bearings, like infrared gun, you'll typically see like a 3 to 5 degree discrepancy from the outside of the coating to the actual bearing surface. But we just sprayed last week a whole bunch of 100 horsepower motors that were not fan cooled. They were big enough that the vents were, an inch wide all around it. So we coated it, and they're getting just deluged with water all the time. So we don't typically coat motors, but if you have a situation where the motor's not running hot, you're not really going to insulate the motor very much. Most of our motors do like output shaft seal area, something where it's getting product in. Also think about gearbox housings. Input output shaft seals is mostly what we do, but we have seen people in real high corrosive environments do the whole gearbox assembly. Show green. So we've got our air pressure set, everything's set. We'll spray a little bit here. You want to allow the flow to work for you, not against you. So you want to spray top to bottom, side to side, and try not to come back over yourself. Try to maintain about a 90-degree angle for what you're spraying. Someone asked about surface prep. This right here is clean enough. We never need to do more than like wire brush, and possibly if the shaft is really corroded, you might want to use emery cloth or something. The biggest thing you want to have clean is anything that's rotating and contacting the coating. But if it's stationary, you're just going to hold in whatever's there. It's not bonding to anything, so you're just going to hold the dirt where it's at. In this case, where there's corrosion, let's say this was your shaft, you would just spray a thin layer of this inhibitor oil on it to make sure that is saturated before you coat it. That way it's not pulling all the oils out of the thermoplastic. But a little bit of this oil goes a long way.
So bonding agent?
No, this is the same oils that you feel in those chips. It's just additional, because if you have heavy corrosion somewhere and you want to make sure that corrosion stops, you want to have leaching of this inhibitor oil everywhere and not draw it out of the coating. As I mentioned, we'll spray kind of in a pattern, top to bottom, left to right. And when you go past the bottom, you want to make sure you get past center, because the bottom is the hardest place to get good coverage, because you can't see it. It's wanting to run off. So as long as you go past center on both layers, you get a good contact area beneath it. Biggest key is full encapsulation, because since we're not bonding to it, we need to make sure that we're bonding back to ourselves. On this application, this is the problem side. We're getting packings start to fail, and they spray water back in this barrel, and you get ingress eventually. So we're going to coat out probably 2 inches onto this shaft, extend the coating probably 3 or 4 inches back here on the barrel. Then between our first and second coat, we're going to put a zip tie around the shaft area, just barely snug, just to keep anything from trying to creep under the coating. And then we'll add our second coat. So that zip tie will be trapped inside the coating.
So you won't be able to go 3 or 4 inches on that barrel with the plane to throw your angle off your phone.
Okay, tell me so we can't go past this?
It all depends, because this unit, you adjust it in and out, so your clamp can sit anywhere on this barrel.
Okay, so maybe we'll just go up to this lip. And then if you're in the field, you need to cut it back more, you can. So we can go further, and then you can cut it according to your clamp. On this side, we were talking earlier, if you have a key already in there, and let's say your bearing or your motor keyway doesn't go all the way to the root of the keyway, just fill this void up with product, trim it flat once it's cooled, then put a thin layer of this inhibitor on the surface there so it doesn't try to bond back into itself when you add your coating that's not going to turn. And that keyway portion fill will rotate in with the shaft.
Would you also put a zip tie on this side after you filled in the keyway?
Yeah,
So any rotating part,
Yeah.
zip tie is
as
recommended.
insurance.
Yep.
Right.
So it's coat, zip tie, coat.
Yeah. You guys have any vertical shaft gearboxes?
No.
If you do, what we would typically do is to keep the water from going into your gearbox seal, you would spray that vertical shaft down around the input shaft hub, and then on a separate piece of shaft, same OD, spray a 2-coat piece, cut it, put it around your shaft right above the coating, and zip tie it so it rotates with the shaft, and that's going to be like your slinger ring. So any water coming down will hit that slinger ring and spray out over it instead of trying to run down inside the coating. And you would also use the zip tie on that. The coating is staying stationary.
I'll just hold up and the whole freezing temperature.
It holds up down to -80, maintains its flexibility. When you're coating, you're probably not going to want to coat much below 0, the actual air temperature. Biggest reason is that it's harder to get the hose and gun warm. And the second is the substrate's so cold that you build a lot more film thickness because it solidifies almost instantly because you're pulling all that heat out of the coating. Other question we get is maximum temp. So if you have a substrate or ambient temperature that's over 200 degrees Fahrenheit, the product's going to start softening again enough to lose its integrity. Over time, it'll lose the oils and it'll become brittle. It won't fall off, it actually gets hard. At about 255, it runs off. So 255 is going to be liquid enough to actually slough off. That gear is the PLC every 20 or 30 minutes. It's got a back flush feature so it blows the moisture out of the tank. Come over here and touch, this is already cool. So it does dissipate heat very fast.
Can you adjust the spray it's like a paint gun?
Not as adjustable as a paint gun, but you can definitely turn your flow down more, turn your air up more. If you turn your air up too much though, it wants to pop, it wants to spider web. You don't get a good film thickness. Try to overlap your seams, so the last place you spray, try to overlap at least 1 inch.
Watch out for line of fire.
Between coats, just trim your drips. That'll help make sure that your second coat gets better flow over the top of the first coat if your drips are trimmed. After the first coat, check for any holes, and if you have a hole, this is the time to touch it up. That should be tight enough that you can still turn this a little bit without it grabbing. So don't over cinch it. That'll just keep you from rotating or turn the product as it rotates. So between coats, you see this oil splash to the surface. It's done the same thing on the inside. So to get better intercoat bonding, wipe that oil off with a preferably like a lint-free rag, something that doesn't have these guys have oils in it. Yeah.
What's the purpose of the zip tie?
It's just insurance so that less can try to migrate up the shaft or try to tear the coating. Anytime you have a shaft protruding on either side and you can't cover the end of the cap, you want to use a zip tie. Within like usually a half to an inch in front of the coating. So this may have melted into the plexiglass a little bit, but once it's cool, it'll peel up. And then that can go back in. Actually, if we raise that again, I can slide that plexiglass under the legs and we can keep all of it. So in your second coat, if your product is still warm, first coat, you can skip the wiping step because you're going to bomb back into the warm material. A lot of times what we'll do is we'll go through and we'll do the first coat on 4 bearings, come behind just doing the trimming, putting the material in your machine, clean the next bearings. So you can do 4 or 5, whatever, first coats. And you want to, when you come along behind it to do the second coat, make sure you do the wiping. But if it's a smaller bearing and it's still warm, just hit it with your second coat immediately. Then on your second coat, you want to make sure you overlap in a different area than your first joint was, just so that if it delaminates at all, you're creating more of a labyrinth for any contaminant to get in. So we'll let that cool before we trim it. It trims way better when it's completely cool. If you want to empty the tank though, like you need to clean the tank out, try to run it low while you're actually spraying. Otherwise it's a long time sitting there holding it. Or you can open up that dump valve in the back.
Yeah.
And get a catch tray to run it into. And it dumps out there way faster.
Just go straight air once the tank's empty.
It'll just cavitate the pump, nothing's going to come out.
How much are the pumps?
I think the pumps are around $800. Okay, let's make this even easier because it looks real easy to maintain that flow across all those substrates. But I would divide this up into quarters. So I would do this space. Like let's say if I go over here and spray and then I come over here and spray for like 15, 20 seconds, this side's cold.
Right.
And it's going to have a lot of drips under it.
Okay.
That's what you do.
That'll work. If you can get it perfectly flat, that's great, but good luck. It's a progressive trigger, so the air always comes out first. So if you're just trying to fill a void, you may want to turn the air all the way off. Let's just scoop that up. There we go. All right, we'll let that cool now. So while that's cooling, let's do this. Start at the top and try to go past the center on the bottom. No. So we cut this coating flat so that we're right inside of the external coating, and we're going to put a thin layer of inhibiting oil on this. Get a little more on there. There you go. And now we can bridge that gap out to the keyway all the way around.
You'll bridge the gap from here to here. And I'm covering this too.
You can cover up some on it, or just that's all the higher we want to go though. And then clockwise until you get a good stream. Angle it out a little bit, you can see what you got. That's pretty good. That's good. So your air's going to come out first when you start pulling the trigger. And if you don't want quite as much material, you can let off a little bit. Your air is always going to be your full strength because it's coming out before the material. Just do one more pass just on this side right here. Go back over itself instead. It's start back a little bit overlap, like an inch. Now once that's cool, we'll put a light zip tie right here. That was not. That doesn't have to be on top. Just a take-up bearing or any kind of a bearing used on a bucket elevator, when you have limited access on the inside, you have the frame and bearing available. Start by turning that over to the inboard side. Put a stub shaft in the cavity and coat the inside of the bearing housing around as far as you can go and up the stub shaft at least an inch. Don't do your zip tie action. But then when you're finished coating that, remove your stub shaft. When you install it, carefully place the bearing over the shaft, and then on the outside, you're going to be coating in and covering back into that area you already pre-coated. And coat around the take-up screw. You can go out as far as you want. Go around your frame. Try to get in as many of these crevices as you can, and go completely around this shaft once it's tightened down, and cover the end of the shaft if that's possible. Then our 4-bolt flange bearing, before you install it, do the same thing. Put a stub shaft in, fill this cavity flush with the back, trim around your stub shaft as high as you can go, remove your stub shaft, slide that on the screw or whatever it's going on to, make your connections, tighten your shaft, and then coat in the outside, completely encapsulating it into the shaft if possible.
Oh, you won't.
Not want to spray up, and then here, make sure that back cavity's full. And I'd like to extend that coating clear out the head face, and then we can completely cover this since that's a straight end. Those other bucket elevators have a slant on them. We'll do a float right around. That's the most vulnerable area. Put a zip tie around the backside.